Hello, my dear students. Today, I am back with a video lecture on the concept called rank correlation. So far we have seen how we can measure the correlation between two variables using Karl-Pearson coefficient or Karl-Pearson correlation coefficient. Okay, so this Karl-Pearson coefficient of correlation is applied only when your data is in ratio scale or interval scale, or if your data is call it quantitative format, then only we can apply this correlation. That means this Karl-Pearson coefficient of correlation. Okay, suppose if the variables are in qualitative form, then we cannot use the Karl-Pearson measure of correlation. Sometimes we may deal with certain data that are qualitative. For example, okay, in a beauty contest is going on, then how we can uh, measure the beauty? We cannot measure the beauty, but we can rank the beauties. Okay, we can rank the beauty. Similarly, intelligence, okay, and many human feelings, many other things that we cannot quantify, but we can rank these things. Okay, so the correlation coefficient obtained through order or rank is known as the rank correlations. Actually, in rank correlation, what we are doing is we don't have a proper value, but we have certain values or we have a certain ranks. Okay, and on the basis of these ranks or on the basis of the order of these values, we can find out the correlation, and this type of correlation is known as rank correlation. Okay, and this correlation concept was first introduced by Charles Edward Spearman. Okay, and he was a biometrician, and it was in 1904. Now, yes, let me tell you how we can find out the rank correlation. Okay, so there are two subjects. One is maths and another one is stats. And there are 10 students. For these 10 students, the different or the ranks which they have got in their maths and stats or maths and statistics. Okay, in first students, ranks in mathematics is 1, but ranks in statistics is 10. Second students, the ranks in maths is 2, but ranks in statistics is 9. Okay, similarly we have this rank, then the person that he has got the last rank in maths have got fifth rank in statistics. Okay, so here what we are having, we don't have their marks. Okay, if we are having the marks, then we can say that it is a quantitative variable, and we can use the Pearson coefficient of correlation. But here we are having only the order of their marks or rank of their marks. Okay, so this rank is a what type of variable? This rank, it's nominal scale, interval scale, ratio scale, or ordinal scale. It is ordinal scale. Okay, rank is an ordinal scale variable. Okay, then what we can do here, we can apply the concept of correlation or rank correlation, which was developed by Charles Edward Spearman. Okay, how we can do that? For that, we have to first identify the differences in the rank. Okay, and this is the rank 1, this is rank 2. Okay, then D is the differences in the rank. Okay, so when we take the differences in the rank, there will be negative differences and positive differences. Okay, so in order to make all the values as positive, we are taking the square. Okay, so we are taking the D square, and you find out this sum of this D square, sum of this D square. Okay, Now there's a Spearman rank correlation coefficient. It is 1 minus 6 into sigma d square divided by n into n square minus 1. Okay, so this is the equation to calculate the correlation in a rank or correlation in a qualitative data. Okay, so it is here 1 minus 6 into sigma d square, it is 234 divided by n is 10, n square is 100, so 10 into 99. So it will be around 1 minus 1404 divided by 990, and it will be around minus 0.418. What does it mean? The ranks in statistics and the ranks in mathematics are negatively related. That means those who are getting higher grades or higher marks in mathematics are not able to score good marks in statistics. Okay, and those who have scored very good mark in statistics, they are unable to score good mark in mathematics. Okay, so this is what is called concept of correlation. Okay, sorry, rank correlation. So why we need rank correlation? Because when there are situations where the ranks or order of these values are available, or order of the variables are available, not the actual data. Okay, in such situations we cannot apply Karl-Pearson coefficient of correlation, because this Karl-Pearson coefficient of correlation is basically aimed at to find out the correlation between two variables that are either ratio scale variable or it is interval scale variable. Okay, yes. Now you see the second problem. Okay, here what we are doing, what we are having here, we are having the marks in English, then marks in mathematics. Here we don't have the ranks. In the first problem we have ranks, but we don't have the marks. But here we are having the marks, but we don't have the ranks. So what we have to do? On the basis of these marks, we have to assign the rank. We have to assign the rank. Okay. Now this R1 is what? Rank in fun. That means marks in English, it's rank. Okay, so you can either rank on the base of ascending order or descending order. Okay, that means from first to last or last to first. Okay, here what I'm doing is I am giving this first rank to those who have scored the largest or the highest mark, 80. Okay, then I have given this 45 to the last person. He has scored, sorry, he has got the last mark, the last score, and his mark is 45. Okay, so I have ranked all these variables. Okay, then second R2, rank in second variable. Okay, so in second variable the highest mark got 77 and lowest mark got 40. Okay, so I have given all these ranks. Now the difference. Okay, 9 minus 4 5, 3 minus 2 1, 10 minus 10 0. Okay, and we have find out the d square also, and finally we have got 54. Then what we do? You substitute these values in the equation. Okay, so in this equation what we need is we need only two values. One is sigma d square and another one is the total number of observation. Here sigma d square is 54 and n is equal to 10. Okay, so it is 1 minus 6 into 54 divided by 10 into 100 minus 1. So it is 324 divided by 990 and 1 minus 0.33, and finally we have got 0.66. From this what we can understand? There is a positive correlation between marks in English and marks in mathematics. That means those who are scoring good mark in mathematics are able to score good marks in English also. Okay, so this is what we called the Spearman rank correlation. Okay, Now here we are having another example, so I'm not going to do that. Okay, so you can try to do this problem and check whether this result is correct or not. Now there may be a situation where the two ranks or two or more ranks are equal. Okay, when we take the real data, if you take the example of your class, if I'm ranking your classes on the basis of your base of the total marks scored, okay, and two or more people may get the same marks or same score, okay, so your ranks will be the same. Okay, so this Spearman rank correlation technique that we have just learned assume that two or more individuals or unit do not have the same rank. Okay, so the equation that we have just used, 6 into sigma d square divided by n square into n minus 1, this equation is applicable only when we don't have these same ranks. Okay, if all people are getting different ranks, then only this equation is applicable. Okay, but as I told you, in many situations there may be certain situation where two or more people may get the same rank. Okay, or this is what we call the tied rank or repeated rank or equal rank situations. Tied rank, equal rank, or repeated rank situations. Okay, so in this situation what we have to do, okay, we cannot use the equation that we have just learned. Okay, so let us see how we can overcome this issue. Okay, for example, we have a series. In the series, the values are 50, 70, 80, 80, 85, and 90. Okay, then I have given the first rank to 90. Okay, second rank to the 85, and for third there are two people, 80 and 80. So what I have to do, third rank plus fourth rank. Okay, what is this third rank and fourth rank? Third is 80, okay, and fourth is also 80, but for this third and fourth there are two peoples. Okay, so what you have to do, you add this third rank and fourth rank and divide with 2. So it is third rank plus fourth rank, it is seventh rank. Seventh rank divided by 2, it is 3.5th ranks. Okay, so what I have to do is I will assign a 3.5th rank to both third person and fourth persons. Okay, so this is 1, this is 2, okay, and this is 3.5. Okay, so 1, 2, 3, 4. So next rank will be 5 and next rank will be 6. Okay, so this way we can overcome the issue of this repeated ranks. Okay, so after doing such kind of a correction in your ranks, you have to correct your equation also. How you can correct the equations? It is 1 minus sigma d square plus a new correction factor will be appeared there. What is this correction? M into m square minus 1. What is this m? How many times a single value is repeating? That will be your m. Okay, and sometime you may have a data in which one single value is repeating. So that time you will have only this value or these corrections. Okay, and if two or more values are repeating more than one times, then you will have a this plus you have to add such type of corrections. Okay, so divided by n into m square minus 1. Okay, so this m into m square minus 1 divided by 12 is known as the correction factor. Is it okay? Yes. Then how we can do this? I'll tell you. We have x and y data is there. Okay, then yes, look at here, first data. This is the first data. We are going to rank. Okay, so which is the highest value? 25. 1. Second, 22. Third, 20. Fourth, 15. Then 14 is repeating 3 times. 14 is repeated 3 times. Okay. So what will be the rank of these things? Okay. So 4 is over. Now fifth, sixth, seventh. Fifth, sixth, seventh. Okay. So if you add 5 plus 6, okay, 5 plus 6 plus, yes, 5 plus 6 plus 7. How much you got? You will get 18. Then 18 divided by 3, it is 6. 18 divided by 3 is 6. Okay. So you will assign this is 6, this is 6, and this is also 6. Okay. So fifth rank plus sixth rank 11. Okay. 11 plus 7 18. 18 divided by 3, it is 6. Okay. So you will assign 6, 6, 6. Okay. So now what remaining there? We have assigned the 6 for fifth person, sixth person, and seventh person. Then only one person is remaining, who is that? Eighth person. Okay. So this eighth person is having, this person, he has got 10 marks. Okay. So we have assigned a 6 rank to 3 person. Okay. Now you take the second value y. Here 40 is the largest value, then 25 is the second value, but 25 is repeating here and here. Okay. So what we have to do? It is yes. Okay. 1 plus 2. 2 plus 3. Okay. 2th rank plus 3rd rank. Okay. So it is 2 plus 3 is equal to 5. 5 divided by 2 is equal to 2.5. Okay. So I am assigning 2.5 to this person and this person. Okay. So 1 is over 2. There are 2 persons, 2 and 3. Now third rank will be for this fellow 18. Okay. Then fifth rank, sixth rank, seventh rank, and eighth rank. Okay. Yes. Now what you have to do? What do you have to do? You have to find out the differences in the rank. Okay. And we have find the differences, and you just square the differences, and you find out the sum of these differences. We have got 83.5. Okay. Now we are coming to the equations. Okay. So equation is 1 minus 6 into sigma d square is 83.5 plus. Now you have to listen. Okay. In x, in rank 1, the value 6 is repeating 3 times. So we are taking 3. How many number of time a value is repeating? 3. Okay. So m is 3. Then 3 into 3 square minus 1 divided by 12 plus. In second R2, a 2.5 rank is repeating 2 times. So 2 into 2 square minus 1 divided by 12. Okay. So we have 2 correction factor here. Okay. And there may be 1 correction factor, 2 correction, 3 correction, 4 correction. Okay. If there are one more value is repeated, then you have to add one more correction. Okay. Then you do the operation. 6 into 83.5 plus 3 into 8 divided by 12 plus 2 into 5 divided by 12. Okay. So it will be all the correction factor would be equal to 2.50. So 83.5 plus 2.50150 is equal to into 6 divided by 504 is equal to 1 divided by 10024. Okay. So we have got minus 0.024. So what does it mean? The relation between x and y are negative, and it is almost very low. Okay, so this is the way how we can find out the rank correlation when there are equal or repeated ranks. Okay, then what will be the limit of this rank correlations? Actually, the Spearman rank correlation is nothing but Karl Pearson correlation coefficient between the ranks. Okay, so here the limit of the correlation will also lies in between -1 to +1. Okay, it won't go beyond +1 or -1. Okay, and if this Karl Pearson is assuming that the population from which the sample is drawn should be normally distributed. For getting a exact value, exact correlation coefficient, there is an assumption, and this assumption is the sample should be normally distributed. Okay, yes. So that's all about rank correlation, and we are moving to the last part of the correlation. Okay, what is the coefficient of correlation? Coefficient of correlation is nothing but if you having a R, that means correlation, Karl Pearson coefficient correlation, okay, and if you multiply this R with one more R, that means if your R square R is equal to 0.5, then R square is what? 0.5 into 0.5. This is what is called coefficient of determination. Coefficient of determination. Okay, and just opposite of this coefficient of determination is coefficient of alienation or coefficient of non determination. It is 1 minus r square. Okay, with this, yeah, then this is not for you. Okay, yeah, so with this we have completed the portion on correlations. Okay, so kindly do watch the video, and if you have any doubts you can ask me in Google in group, or you can personally text me. Thank you.